So yesterday we were discussing about magnetic field, right?
Yes, sir.
Straight conductor, right?
Yes, sir.
This one I demonstrated this. Okay, so
Yes, sir.
next I will show you that rule. Yesterday, do you remember that magnetic field is like spirals, right?
Yes, sir.
Okay, the rule, this rule is given by Ampere. This is called Ampere's rule.
Yes, sir. Yes, sir.
This is called Ampere's rule. Just you, yes, here it is. Able to see it?
Yes, sir.
This is the current flow. Current is passing through that wire. This is the compass. And this is the direction of magnetic field, right?
Yes, sir.
So you can, right?
Yes, sir.
You can watch by moving the compass that magnetic field direction is nothing but the tangential direction. If I flip the current, what happens? Just watch it, right?
Yes, sir.
Okay, what is that thumb is showing?
Current?
This thumb, yes, exactly correct. Thumb
Yes,
is showing
sir.
the current. This one, how we roll our fingers to make this.
I think that's the magnetic lines.
Yes, magnetic lines.
Yes, sir.
Exactly, that indicates. This is the small gesture or indication given by Ampere, and this is well-known law. This is called Ampere's law. And this right-hand thumb rule, it is also known as a simple method. You can use this gesture and then you can understand what exactly the current direction and what is the magnetic field direction.
Yes, sir.
Right? So
Yes, sir.
you put that right hand. Upward means, now it is very famous in WhatsApp messages, right?
Yes, sir.
Thumbs up and thumb down.
Yes, sir.
So almost every day we use this gesture. Now it
Yes,
is very famous for different purpose, but here we are using it to indicate the current direction and magnetic field direction. Okay, what is the value of magnetic field that is produced because of the current? Right, that is formula is given. Unfortunately, that formula derivation and everything is not there for you,
Yes, sir.
but you can derive if you want from the previous experiment. We conducted this one, right?
Yes, sir.
Relations I already demonstrated. As we move away from the conductor, magnetic field gets decreased, right?
Yes, sir.
Okay, now you can see the relation. It is B is the magnetic field inversely proportional to D, right?
Yes, sir.
Directly proportional to I. So if I remove the proportionality, I am considering one constant term. This is called mu by 2 pi. You know the meaning of it. I think that maybe you might have heard about this.
I
Mu by
heard
2
it,
pi.
sir. I'm not sure what it is.
Okay, what exactly the meaning and everything we discuss later, right? But that is not
Yes,
there
sir.
for you. But we can discuss about it, how exactly it is, what exactly it is there any connection to the electric field, and everything we discuss, right?
Yes, sir.
Okay, so this is only to demonstrate, right? And
Yes,
you
sir.
can see this is the demonstration, and this is side by side, right? Up and
Yes,
down,
sir.
current up and down, side by side demonstration. And you can see at the same time, you can see the magnetic force, right?
Yes,
They're
sir.
opposite because current is opposite in direction, right? This is
Yes,
by
sir.
side demo. These are the magnetic lines shown, various magnetic lines, right?
Yes, sir.
You can see at each and every height, different heights. This is nothing but different heights. If you want, you can rotate this and then you can verify, right?
Yes,
They
sir.
are from the different distances, right? So each one is
Yes, sir.
having its own magnetic field. You can see the length of the arrow. Length of the arrow is the indication of magnitude of magnetic force, right?
Yes, sir.
You can reverse and verify. So these are the 3 or 4 views that you can use. 2, 3. Yeah, this is the 4. Nothing is given here. You have to observe and then you can once again get the idea. Okay, now the next observation is a bit different one. Previously, the conductor that we used is in the shape of a straight line, right?
Yes, sir.
Now, what is the shape of that conductor? It is a circular arc, right?
Yes, sir.
This one. Now, what is the magnetic field? How it looks? Is it similar to the previous one or is it different? What it looks or how it looks?
Different, sir.
Different. How? In which way it is different?
Its shape is different.
How? Previously,
It was
the...
spiral.
Okay, now?
Now it's like a hemisphere.
Sure.
Yes, sir.
Look at this point. Go through these compasses, right?
It's still in a spiral, sir.
Here.
But sir, this time they added a battery and a switch.
Okay, that's also there in the previous one. Isn't it?
Yes, sir.
Sorry, not this one. This one.
Yes, sir.
No battery or
Yes.
battery? Battery must be there because I want to supply some current, right?
Yes, sir.
What is the difference? Previously, there was only one, right?
Yes, sir.
Now we have
Two.
2. Okay. Now this is acting like what? One magnetic pole, right?
Yes, sir.
This one, another magnetic
Another
pole.
one, second one.
Now you compare this one and this one. The same location, similar
They
locations.
look exactly the same, but one is in different directions.
Yes, opposite exactly. You can
Yes,
see this one. Similar locations. You observe the compasses at similar locations. What exactly this means? Magnetic field direction is exactly opposite, right?
Yes, sir.
Means current, how the current should be? In the same direction or in the opposite direction?
Opposite.
Means here current will be downwards. Suppose, let us consider this side. Okay, instead of this, I make use of this one so that I can annotate.
Yes, sir.
Here I consider, suppose current is downwards, right?
Yes, sir.
And here the current will be definitely opposite, means upwards, right?
Yes, sir.
So this is the difference between the straight conductor and the current loop. This is called current loop or circular coil. What I considered only half circle, right? Hemisphere like.
Yes, sir.
Okay, here. But if I join these two, how it looks? This is like one magnetic pole. This is like,
Another one, sir. Yes.
yeah,
Sir.
this is like one magnet. This is like another magnet. So here I am having one magnet. Here I am having another magnet. So I have two magnets now. So what is the difference? For straight conductor, how many magnets? It is behaving like only one magnet.
Yes, sir.
But here it is acting like two magnets, right? Isn't it? Here one magnet, here another magnet. So it is behaving like two magnets, right? Hello? 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 Hello.
Sir, am I audible?
Yes, you are audible now.
Yes, sir. Once can you
Okay.
repeat, sir?
Yes, I am repeating. So here it is acting like one magnet. Here this is acting like another
Another
magnet.
Yes, sir.
Okay, they are similar. Now you can see this. Exactly. It is very same, right? Isn't it?
Yes, sir.
Magnetic field is like circulating, right?
Yes, sir.
But here it is in opposite direction. It is rotating in this direction. Here, if I come, it is rotating in another way,
Yes, sir.
right?
Yes, sir.
So it is behaving like two magnets, not a single magnet. Its behavior. If you want, you can confirm through the magnetic field diagram. You can see the magnetic field diagram of two magnets, right?
Yes, sir.
Okay, how does it look? If you compare with that one, definitely it is behaving like two magnets, right?
Yes, sir.
Okay, so these two magnets placed side by side, they are of similar in nature or dissimilar? What do you think?
Similar, sir.
Definitely they are similar. How you can say it or how you identified it? You got my point?
Yes, sir.
How can you say that this and this both are like similar? Our same poles are facing each other. Our opposite poles are facing. Which one is correct? What do you think? This is like one magnet, right?
Yes, sir.
Okay, shall I draw it so that you
Yes,
can?
sir.
Shall I draw?
Yes, sir.
This one, look at this. Suppose here it is north and obviously this will be south, right?
Yes, sir.
This one, what do you think? This one is like north or south? What do you think? That's what I am asking.
I think that one's not.
This one, north.
Yes, sir.
Sure?
Yes, sir.
You think that it is north?
Yes, sir.
How?
Sir, because they're going in different directions. I thought.
Okay. Okay. You observe once again the magnetic lines. How these are? Here these are like this, right?
Yes, sir.
Here these are like this. Right?
Yes, sir.
Now you look at this. Okay.
Sir,
Are they
maybe it is south.
just watch these two?
Yes.
Okay, I make it bigger one. This one and this one. How they are? How they are? They are opposite or
They are together, but they're opposite. Directions are different.
these two?
No, sir, same.
They are aligned in the same
Yes.
direction, right? These
Yes.
compasses means what? These are aligned.
It means they are all having same field.
Here you look at this, these three and these three, but along this direction, right? Along this line. They are the same, okay?
Yes, sir.
So what exactly that indicates? Magnetic lines, I think it is there in your 9th standard, I think. Magnetic field lines of two
Sir, it was
magnets.
deleted, sir.
Two magnets.
Yes, sir, it was deleted last.
Okay, I will show you. How will show you actual the diagram, right?
Yes, sir.
Then you can guess. Where is this? Annotate. Okay, I clear these diagram drawings and then I try. If I am correct, I have physics, media. Yes. Are you able to see it?
Yes, sir.
Okay, look at this. Right?
Sir, I don't think they are just different, sir. I think both are not
These are different or same?
different, sir.
Yeah, they are different. One is north and one other is south. In this case only, you will get all the middle one. You look at this.
Yes, sir.
All are aligned, isn't it?
Yes, sir.
So you get this type of field lines when they are opposite to one another.
So you are not audible.
Here it is like small magnet. Here it is like another small magnet.
Yes, sir.
This is north and this is south. This type of arrangement facing this one is called dipole, right?
Yes, sir.
Equal and opposite. So both magnets, right?
Yes, sir.
So this is called the dipoles. Okay, so there are another possibilities: north north, south south, and south north north south. Those are the possibilities. So this arrangement is called dipole. So what is the behavior of this one? It is behaving like a magnetic dipole. What exactly this one is? What is the advantage of this? When we are going to use such dipoles and everything we discuss, that is there for you, right?
Yes, sir.
Yeah, this is the current loop. What is the current loop and how the magnetic field is with for this current loop? Up to this only you have no derivation, nothing. Everything
Yes,
is there in the intermediate, right? So
yes,
for you, there is only a demonstration. What is the magnetic force, how it is, what is the direction and how it behaves and everything that you can see very easily. So for the straight conductor, the current is straight conductor, magnetic field is having only are behaving like only one magnet. Here it is behaving like two magnets. At one point, the poles are opposite to the other one.
yes, sir.
The same principle if you apply to this one. Okay. Now, instead of single loop, here I am considering how many loops? 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This
Yes,
is
sir.
called spiral. This is also known as, are you able to see it?
Yes, sir.
What is this called? Solenoid,
Yes,
right?
sir. Sorry, my yes.
Solenoid. What exactly solenoid is?
It's a conductor with wire around.
Wire. Okay, you forget about this one first. You concentrate on the wire, right?
Yes,
It's a
sir.
spiral. Spiral with single loop or multi loops, right? Or you take a straight conductor and then take any pencil or and then something you wind it around that, then you remove that pencil or whatever it is, then the shape whatever you get is called, sometimes we call it a spring, right?
Yes, sir.
In general it is called spiral. Okay, that spiral in physics, we call this one as solenoid. When spiral, it carries some current, then it is called solenoid. So
Yes,
now
sir.
around this solenoid, you are able to see the magnetic field, right?
Yes, sir.
Yeah, instead of compasses, I can show you through the arrows. Arrow indicates the field direction or force direction, magnetic force direction. Both are the same. And you can see the, or you can apply the right hand thumb rule to identify the direction of magnetic field and flow of current.
Yes,
Is it
sir.
correct?
Yes, sir.
Yeah. You can switch the current direction. What is happening to the magnetic field direction? Getting reversed,
Yes.
right?
Yes, sir.
So when I reverse the current flow, automatically the magnetic force is also getting
Inverse.
reversed. Yeah. Instead of current, now what I am doing? Just watch. What I am doing?
You are holding it.
No. Just watch once again. Watch it carefully. I am not explaining. I am giving you the chance. What are you observing?
Sir, we are flipping that solenoid, sir, front to back. So, because of
What,
its directions are changing.
what exactly it means?
We are turning the solenoid, sir.
Yes, turnings are opposite. Previously, I might have wound that solenoid from left to right. I am
Yes,
flipping
sir.
it means it as if it is wound from right to left, just like languages, Urdu and Hindi.
Yes, sir.
They write from right to left. We write from left to right. So
Yes,
I
sir.
start from left to right. That is one way of winding it. I can start from right to left. Both are different. Why? Because the current flow will be the opposite way, isn't it?
Yes, sir.
So that winding also matters. In which way I am winding it. If I start from left to right, current will be flowing in one way. If I start winding from the other way, the current will be in another direction. That is the reason why the magnetic field is also flipping, right?
Yes, sir.
Right. So instead of arrows, I can use the compasses to show. Arrow will be very clear. So this is it. This is the right hand rule to compare whether the diagram is showing the correct or not. Okay,
Yes,
this is the correct one. This is the demonstration of current in a solenoid. So what is a solenoid? Solenoid is nothing but a conductor on which a wire is wound. Even without the conductor also we can use it. That is also called solenoid. Sometimes you will place the conductor. Sometimes we remove the conductor, whatever it may be. It is like a spiral,
yes, sir.
right? A spiral wire. Simply, wire is also a conductor. Sometimes I can place just like this one, that gray rod is there, cylindrical rod. I can keep a metallic rod inside of this. Will there be any effect of it or not? That you can estimate, but that is not there for you. It is there in intermediate, right? But you
Yes,
can
sir.
observe. We have some activity later. We can see whether there is change in the magnetic field or not because of the introduction of this conducting material, inserting this material inside of that spiral coil, which is called solenoid. So basically solenoid means a conductor conducting wire wound or wind in the form of a spiral, right? Two ends of that one is connected to some battery or current source, so that current will be flowing through it. So a current carrying spiral is called simply a solenoid. It has of two types. It is of two types of windings,
Yes,
left to right or right to left. So what is the effect of it?
directions are changing.
Yes. It is very similar to switching the current direction.
Yes, sir.
Okay, that's the point.